Saxon's Trig lesson 117 is about prime and relatively prime numbers and then rational roots theorem, which is the shortcut that I said other than just the circular region of interest that we were using from before. But before we get into that, the prime and relatively prime numbers. You know that a prime number is a number that can be split up into something other than just one and itself. So 4 would be an example of a prime number because it can split into 2 times 2. And a non-prime number such as 3, the only way to get 3 is 3 times 1, so it's not prime. And you've been doing those for quite some time. I don't anticipate that that's any kind of a problem. What might feel a little new is the relatively prime numbers. So if you have two numbers and they do not share a common factor. In other words, these two would be relatively prime because they don't share, this doesn't have a 3, this doesn't have a 2, they don't share any sort of a prime. So we call them relatively prime numbers. And then they go into some other explanation which is sort of helpful, but not to the application of what you need to be doing. It was just sort of interesting to read through. And then in part B, they're like, okay, now let's talk about why did we care about the relatively prime numbers. So when we have a given equation, I was looking for their example. Okay, so negative 2x cubed, this is example 1, plus 3x squared plus 2x plus 5 equals 0. You are looking for the coefficient to the highest exponent value, which is the negative 2, and you're looking for the one that doesn't have an x. So if you pull those two numbers and you list all of their factors, and you put the 5's list in the numerator and the coefficients list in the denominator, you have found the rational roots. So basically, I'm talking about the factors of the constant over the factors of the lead coefficient. And if you want that in your notes, that's fine. It can be a very helpful, or you can just memorize that it's that way. But if you need this to kind of help keep you on track, that's great. So what are the factors for 5? 1 and 5, and we're going to put those in the numerator. What are the factors for, and I don't care about the negative part of that, what are the factors of 2? 1 and 2. So now that we have those, the way we get our actual numbers to test is and they're doing that weird thing that I said was interesting, but not, just jump to this. All right, so what you're gonna do is you're going to list in both its positive and its negative format, the combinations of these. So 1 over 1 is 1, positive and negative. 1 over 2 is a half. Positive and negative 5 over 1 is 5, and positive and negative 5 over 2 is the fraction 5/2. These are the specific numbers that I would use to test in my synthetic divisions to determine if they are 0 answers or not, or they're going to give you the other dot that you can graph. So the circle is helpful, but these are the definite specifics. And at least one of these will have to give you an answer, a 0 solution. Now, example 1, which I pulled for the thing, I didn't read the actual question. Use the polynomial equation to develop a specific proof for the rational roots theorem. We're not going to do that because it requires the weird thing about factors. You're going to take my word for it at this point and jump to that. And so it wasn't looking for this list, but I provided you with that list. Now, example 2. Apply the rational roots theorem to list the possible rational roots of the equation. Okay, so here's the next one. 4x to the 14th, my goodness, plus 3x to the 8th, plus 7x plus 3 equals 0. Now I realize that this has nothing to do with my rational roots theorem, but I could have up to 13 curves in this graph. I'm glad they're not asking me to graph it. So we want to pull the coefficients from the non-x term for the numerator and from the lead coefficient, the 4, for the denominator. So that's 3 and 1 for the numerator, and 1 and 2 and 4 are the factors for the denominator. So we're going to have positive and negative. 3 over 1 is 3. Positive and negative 3 over 2. Positive and negative 3/4. Positive and negative 1 over 1 is 1. Positive and negative 1/2. And positive and negative 1/4. Now that should be the list. Let me make sure I didn't skip any. They're going to be out of order. 1, the half, the 4th, okay, and then the 3 halves, and the 3/4. Yep, I did not miss any. That is the list of possible things to test. Now in an upcoming lesson, then they'll have you begin to use those to actually do the graph.